2. So this will not take a whole lot of work when you're finding the inverse of a matrix. We use inverses to solve equations, except we don't have to ask you to solve equations at this level. We're just teaching you certain operations that you might do with inverses, and later on when you get to another math class, you can use those operations to do things like solve equations. So when you're finding the inverse, we can do a little formula here. So we'll write a formula down for you. You won't see the absolute value bars because we're not finding the determinant, but we'll do a general formula. When we do a general formula, you know, we can just use letters that says this applies to all 2 by 2 matrices, 2 rows and 2 columns. So the formula for finding the inverse looks like this. It's 1 over, so the first part's going to be a fraction. 1 is always going to be in the top. In the bottom of that fraction, you're going to have A times D minus B times C. So your inverse is going to have a scalar left out in front of your final answer. And your scalar is going to be 1 over AD times BC. And then you'll do your little brackets. And this is where we do some changing, okay? We're going to do some switching first. We're going to take the A and the D term and actually switch their places. We're going to switch the place of the A and the D, and we're going to change the signs of the numbers that are located where the B and the C are. So to show that in our formula, if we change the sign of something, we can just make it negative. That means if it's positive, it turns into a negative. That means if it's negative, it turns into a positive. So you're going to do 1 over AD minus BC. You'll simplify that. That'll end up being your scalar. You don't multiply the scalars into the matrix when you're finding the inverse. You actually just leave the scalar on the outside. You switch the A and the D term, bless you, and you change the signs on the B and the C. Now, some matrices do not have inverses. So if A times D minus B times C is equal to, anybody want to guess? 0, okay, we say that no inverse exists. If A times D minus B times C equals 0, that means we would have 1 divided by 0, which we know is undefined, then that matrix doesn't have an inverse. All matrices don't have inverses. Most of them do, but some of them don't. And you'll know that a matrix doesn't have an inverse if your A times D minus your B times C is equal to 0. So if that happens, you just stop. You don't do any of the switching the A and the D and changing the signs. All right, so that's your formula. Let's look at an example. What example number are we on? 7. Okay, let's go to this page so we have a little bit more work. Alright, so if we have, let's look at one like this. If we have 2 and 1 and -3 and 7. So they'll give you the 2 by 2 matrix, and the directions will say find the inverse of each matrix. So you're going to start the formula by doing 1 over, and then you're going to do A times D, that's 2 times 7, which is 14. The formula says subtract, and then -3 times 1, or 1 times -3, that's -3. And then you're going to switch the places of the 2 and the 7. So that means the 7 moves to the top left and the 2 moves to the bottom right. And then the 1 and the -3 don't move, but their signs will change. So the positive 1 turns into a -1, and the -3 turns into a positive 3. And then you're almost finished. All you have to do next is just simplify your scalar. So 14 minus -3 is really 14 plus 3. So your scalar comes out to be 1/17. And they allow you to leave the scalar on the outside because usually the scalar is a pretty ugly fraction. And they don't make you multiply the scalar in. Once you use this inverse to solve an equation, you don't want that 1/17 multiplied in because it makes your math harder. So you can leave that actually outside of that when you use the inverse to solve equations in another math class. All right, questions about that process? All right, so that's a problem that has an inverse. Let's look quickly at one that doesn't have an inverse. Can anybody make me up a problem that's not going to have an inverse? Too early in the morning. Come on, somebody can. 2, 1, what? 2, 1, 8, 4. She's got it going on. So I would do 1 over, and then I would do 2 times 4, which is 8, minus 1 times 8, which is 8, and then I would just stop. There's no reason to work this problem any further because you know 8 minus 8 is 0, and 1 divided by 0 is going to be undefined. So this matrix is not going to have an inverse. So you will just write no inverse. Can you think of anything to ask about finding an inverse? Because that's kind of it. They're all 2 by 2s. Some matrices have inverses. If they do, you'll do the formula. You'll leave the scalar on the outside. You will have to know the formula tomorrow. Any questions? All right, on the back of last night's homework, you have 10 inverse problems. You're going to flip those over right now in about the next 10 or 15 minutes, and you're going to work those. I'll call out the answers, and then we're going to work on a review.